Thank you for choosing Teledyne Dalsa's Z-Trak family of high-performance line profilers. When scanning objects with a Z-Trak profiler, the laser light is reflected back to the profiler sensor and the height of each pixel along the x-axis is calculated. However, depending on the type of material being scanned and its shape, the laser light may be reflected, creating artifacts of non-existent points. Shiny or metallic surfaces are particularly prone to producing scattered reflections. In this example, we will use a metal screw which, due to the parallel vertical threads, presents a worst-case scenario for reflections as the laser light bounces between threads. This is particularly evident with the incident laser light at the middle of the screw. The Z-Trak App Studio includes a surface preprocessor to eliminate these unwanted reflection points. Other surface preprocessors are then used to further enhance the scan quality. Although we will be using Sherlock for this tutorial, the surface preprocessors and their parameters apply to all development platforms. First, we need to add a cuboid ROI for the surface. We will hide the ROI to better show the effects of the preprocessors. We now will add the Surface Eliminate Reflections preprocessor. The default settings work well. However, if necessary to improve the performance on a particular image, you can adjust the preprocessor's parameters. The Isolated Surface Removal Threshold parameter allows us to remove points that do not have close neighboring points, which often indicates a reflection. For this example, the default setting of 200 micrometers effectively removes most of the reflection points that appear above the screw surface. The surface quality factor determines the strength of the reflection elimination algorithm. The higher the value, the more aggressive the removal. For this example, we find that the default setting of 15 is effective for this surface. To replace the removed points, we can now use the Surface Fill Gaps preprocessor. Again, the default gap size X and size Y of 200 microns works well. Higher values will fill larger size gaps, which is not necessary for this image. Finally, to improve the surface quality, we can use the Surface Smooth preprocessor. The default 5x5 kernel performs this task well. We hope that this tutorial will help you to use the Z-Trak App Studio preprocessors to eliminate unwanted reflections and improve the surface quality in your Z-Trak scanning applications.